Hi, my name is Juan Fuertes Otoya. I am a student of electronic engineering. The topic that I present to you is uncertain electromigration and the IR job in SoC design. Introduction. As we push drug lower technology nodes in the IC in chip design, they were with gas thinner along with transistor side. This makes the wear resistance more dominant on 16 nanometers and below technology nodes. This increasing resistance and the decreasing width of metal were introducing mainly electromigrations and IR drop indices. These two uses play major roles in reducing the lifespan of electronic device and are the causes of the functionality failure in any electronic device with lower technology nodes. What is electromigration? Electromigration is a molecular displacement to the motion transfer between conductive electrons and ions over a period of time. It occurs when the density of the current is high, which causes the metal ions to drive in the directions of electron flow. Usually occurs after years of development of device in the field. Due to the electromigration effects, the metal wires might burn into open and short, can increase wear resistance, which can cause a voltage drop resulting in device slowdown. It can also cause permanent failure in circuits due to short or opens, thus in a positive feedback loop with temperature. Here how to find the mean time the Fuller MTTF of a metal I will bleak equations. Electromigration relativity of aware Black equations. MTTF A cross-section area dependent constant Jn current density A sub E E sub A activation energy K Boltzmann constant T temperature in kelvins and scaling factor usually set to 2 according to Blake.
Today's PCBs and packages are getting smaller, and so are their interconnects. Shrinking interconnect cross-sections create many reliability concerns. With 5G on the horizon and rising demands for high data rates and low latency, these power-hungry electronic devices can overheat in harsh environments and fail over time. ANSYS SI-Wave can perform electrothermal simulation of complete boards and packages, and uses the results to predict electromigration effects in interconnects. It estimates their lifespan and identifies potential points of failure, allowing designers to find reliability problems that might slip through the cracks before fabrication. Among other metrics, SI-Wave quantifies electronics reliability by predicting the failure rate of every interconnect in the layout. This leads to a cost-effective design whose reliability meets the application's requirements. High currents flowing through an interconnect produce an electron wind that can dislodge atoms and transport them away. This causes voids to form in the metal, increasing their resistance and leading to potential open circuits. This electromigration effect is often modeled by Black's equation, a probabilistic model that predicts the mean time to failure, or MTTF, as a function of the current density and the temperature. This virtual prototype consists of an FPGA package mounted on a PCB. To account for current flow effects, a DCIR simulation is performed in SI-Wave. The results show the current density in the design. Electromigration is a strong function of temperature. You can perform thermal simulation in ANSYS IcePack to get an accurate picture of the board's temperature distribution. Graphical feedback helps to visually identify areas where electromigration effects may lead to damage over time. In addition to the MTTF plots, SI-Wave displays warnings and errors ranked by predicted mean failure time and severity. Navigate to the regions above or below a specified MTTF error threshold, or zoom into the vias and bond wires to locate the affected component. When the chip draws 6 amps, the mean time to failure is over 200 years. Nothing to worry about. But if the chip were to draw 24 amps, its lifespan reduces to just over 6 years, and at 30 amps it drops to 1.5 years. Simulate PCBs in ANSYS SI Wave to easily identify and resolve potential electromigration issues and boost electronics reliability. To go even deeper into the detailed physics of electromigration at the individual component level, consider ANSYS Mechanical.
This is Electromigration. What is IR drop? IR drop is a voltage drop in the metal wires connecting the power rail before it reaches the power pins on the start cells. It becomes very important to limit the IR drop as it affects the speed of the cell and overall performance of the chip. There are two types of the IR drops: static and dynamic. A static IR drop is an average voltage drop for the design. It is dependent on the RC of the power rail connecting the power supply to the respective standard cells. The average current depends totally on the time period. Gate channel leakage current is the major reason for the static IR drop. Dynamic IR drop. Dynamic IR drop is a drop in the voltage due to the high switching activity of the transistor. It happens when there is an increasing demand for current from the power supply to the switching activities of the chip. Dynamic IR drop depends on the switching time of the logic and is less dependent on the clock period. Dynamic IR drop evaluates the IR drop caused when a large number of circuit switches at the same time, causing a peak current demand. Applications. Applications in the electronics. All electronic devices that we use on daily basis can be affected by it. All computers and desks or smartphones or tables and any other device that incorporate semiconductors inside can be the victim of the electromigrations. Pros and cons. Pros: chains of wiring for communication lines. Cons: mass transportation induced failures. Second, short circuit or open circuit. Studies in Ecuador. Electromigration is studied at the Catholic University, which is the transport of material caused by the gradual movement of ions in a conductor due to the moment transfer between conducting electron and diffusing metal atoms. Conclusions. When it comes to lower geometries design, the use of IR drop and electromigration are common, with technical like fading on clock cells, resting maximum load on net, and applying NDR on clock net. You can prevent major IR drops used and reduce electromigration in lower geometry shift times. Thank you.